Okay, we are starting with surface tension. It is a part of fluid mechanics. Okay. Now, what is surface tension? For that, first you have to recognize what you mean by a free liquid surface. Correct. So, any surface that is not in contact with any other immediate surface is called a liquid surface. So, to begin with, what we do over here is we take a free surface of a liquid. So, let us say that this is a free surface liquid, and we draw an imaginary line on this liquid. Because of this, the surface actually appears like an elastic membrane. So on both sides of the imaginary line that we have drawn, there will be force present. Okay, I cannot draw all the forces, but some of the forces I have drawn. So the ratio of force per unit length is termed as surface tension. So to write it in terms, we say that surface tension is the force per unit length of a imaginary line drawn on the free surface of a liquid. Okay. So that is surface tension, and as the formula suggests, T is the surface tension will be F upon L. So its unit will be Newton per meter. Its unit will be Newton per meter. Is this clear?
Yes,
So
sir.
did you understand surface tension?
Yes, sir.
So now to further understand surface tension, we have to understand about the molecules that exist in surface tension. So remember that every molecule, whether it is in solid, liquid or gases, exerts other molecules in and around it, whether it is of the same material or if it is of other material. So if you look at two molecules of the same type, then the force between them, is called as force of cohesion. On the other hand, if you have two molecules of different type, the force of attraction between them is called force of adhesion. Okay, so we have two type of intermolecular forces that we are discussing here. One is force of cohesion and other is adhesion. Force of adhesion. Okay, so force of cohesion is intermolecular force between molecules of सेम सबस्टन्स. म्हणजे वॉटरचा वॉटर बरोबर, मर्कुरीचा मर्कुरी बरोबर, ह्या मॉलिक्यूलमधले जे फोर्स असणार त्याला आपण फोर्स ऑफ एडेशन म्हणतो. करेक्ट? ओके, अंडरस्टूड दिस करेक्टली? नाउ
Yes, sir.
फोर्स ऑफ कोहेशन विच वी डिस्कस जस्ट नाउ. करेक्ट? So force of cohesion will be force between molecules of different atoms. Correct?
Yes, sir.
So we can say that force of cohesion will be force between molecules of different substances. Correct? Okay, is this clear?
Yes, sir.
Okay, one second now. Yeah, so here we are talking about force of adhesion and force of cohesion. Coming back to what we just discussed, we talk first of all force of cohesion. So what is force of cohesion? Force of cohesion is intermolecular force between molecules of the same type. Force of adhesion is force of intermolecular force between molecules of different type. Is this clear?
Yes, sir.
Okay. Acha. Now, once we have zeroed in this on two types, one is force of adhesion and cohesion. Now we look further into it. We look at a molecule per se. So let us say we are taking a molecule here. Then this molecule, the force of intermolecular force exerts only up to a certain distance. म्हणजे it will attract all molecules which are at a certain distance from it. Okay, this distance is of the order of 10 raised to minus 9 meter or nanometer. म्हणजे एका मॉलिक्यूलचा दुसऱ्या मॉलिक्युलर वर फोर्स तेव्हाच असणार जेव्हा इट विल बी विदिन दिस रिजन. करेक्ट. ओके, यालाच आपण दुसऱ्या पद्धतीने असं लिहू शकतो की इफ देर इज अ मॉलिक्यूल then it will attract all molecules which are within a space or which are within a sphere whose radius will be within that. Correct. So radius किती असला पाहिजे? Radius should be, as I told you, 10 raised to minus 9 meter. याचा आतमध्ये जितके मॉलिक्यूल असतील त्यांना तो अट्रॅक्ट करू शकतो. लक्षात आला का? हॅलो. करेक्ट. हा जो डिस्टन्स आहे दॅट डिस्टन्स इज कॉल्ड radius distance of molecular influence. It's called distance of molecular influence. So this is primarily called as distance of molecular influence. आणि त्याच्यामुळे जे स्फियर होणार दॅट इज कॉल्ड स्फियर ऑफ मॉलिक्युलर इन्फ्लुएन्स. सो दिस इज कॉल्ड स्फियर ऑफ मॉलिक्युलर इन्फ्लुएन्स. ठीक है.
Yes, sir.
The sphere is called so did you understand radius of molecular influence and sphere of molecular influence? Instead of calling it radius, we could very well call it as radius of molecular influence because that would be better term used. So we call this as radius of molecular influence. Okay. So we have got radius of molecular influence and we have got sphere of molecular influence. Is this idea very clear to you? Hello.
Yes, sir.
Now to further explore, we take a particular liquid in a container. Correct. So आपण एक container घेऊया and then we will take liquid in it. So here is our container and in it we have taken liquid to a certain level. So let us say that we have taken this liquid here. Okay. Now inside this we talk about three molecules. So the first molecule, let us name that molecule as A, is deep inside the thing. We will call this A. आणि याची मॉलिक्युलर इन्फ्लुएन्स जो आहे तो कम्प्लिटली लिक्विडचा आतमध्ये असेल. याचा अर्थ असा आहे की याला सर्व प्रकाराने सर्व साईडमधून फ्रॉम एव्हरी डायरेक्शन इट विल बी अट्रॅक्टेड बाय द अदर मॉलिक्युल्स ऑफ द लिक्विड. करेक्ट. So the net force on it, net intermolecular force on it will be 0. Okay, so it will be like this. If you take a molecule near the surface, then if you notice carefully, you will see that the sphere of molecular influence will be partly inside the liquid and partly above. So here there will be a net downward force acting on this molecule. Let us call it as B. Now if you take a molecule which is exactly on the surface, then half its molecular influence will be outside and half will be inside. So it will have the maximum force acting downward. Okay. Now whenever a molecule goes from the inside to the surface, it has to do a certain amount of work against this intermolecular forces. That work gets converted into what is called as surface energy. So we say that all molecules on the surface of a liquid have got extra potential energy which appears only on molecules on the surface, and therefore we call it as surface energy. Okay, is this clear? Hello.
Yes, sir.
हां, तर याला आपण एस असं डोनेट करूया. आता आपल्याकडे दोन वस्तू आहेत. एक आपल्याकडे आहे सरफेस टेन्शन, जे आपण मागच्या पार्टमध्ये शिकलो आहे, सरफेस टेन्शन. And additionally we have got something called as surface energy. So now we want to find out the reason for surface tension. See, if you look at this particular section and say that our molecules will be here at this particular, the molecules will be existing at this point. So we say all our surface molecules will be at this point, correct? So all of them are here. This will have more energy than the molecules in fact. Now remember, this potential energy which we are talking about, we would like to keep it minimum. So du by d x, correct, dx should be minimum, should be 0, or other words potential should be minimum. Now why is this condition? This condition is important for attaining equilibrium. Attaining equilibrium. Now remember, here there is no external force, so equilibrium has to be brought out by reducing this surface area. So this surface area which we are talking about has to be reduced, and in doing so the free surface appears to be as a elastic membrane. म्हणजे चारी बाजूंनी त्याला ओढल्यासारखं वाटतो, त्यामुळे कुठलाही आपण असं जर भाग घेतला तर बोथ साइड्स यू विल गेट फोर्स. डिड यू अंडरस्टँड द रीजन ऑफ सरफेस टेंशन? Hello.
Yes, sir.
Okay. Now we want to find out the relation between surface tension and surface energy. So let us say that we take a frame this way. Now remember, this is a fixed frame. On top of this fixed frame, we have kept a movable part here, correct? And this whole thing, let us name it for our own convenience. Let's call it as A, B, C and D. Now this is dipped in soap solution. When you remove it, there will be a soap film. So here we will have a soap film, correct? Now remember, a soap film has two surface areas on the top and the bottom. Now we apply a very small force F such that the film doesn't break, and this CC dash moves to a little ahead, C dash D dash. And let us say that this distance, this forms an extra film. This distance is dx, okay, and let us say that the length of the rod is L. So the extra energy, extra area that we got, dA, will be equal to L into dx. Now there are two surfaces up and down, so actually the net area will not be d into dl, but it will be 2 times L into dx. Did you understand why it is 2 times? एक वरती असणार, एक खाली असणार, ठीक है? Hello?
Yes, sir.
Now the amount of work done by you will be equal to force into dx. Now force, as far as we know, surface tension is equal to force upon length. Now there is two length, one on the upper side, one on the lower side, so in this case it will be 2L. So your F will turn out to be T into 2L, correct? So here your dW will be equal to T into TL into dx. Now this will be equal to area, so surface energy will be equal to surface tension into surface area, okay? So change in surface energy will be equal to surface tension into change in surface area, okay? Let us write it down so we remember. So you look at this, change in surface energy is equal to surface tension, which is a constant, into change in surface area. Is it clear? Did you understand this
Yes.
part? Okay.
Yes, sir.
Fine. So if you want to make a note of it, you can make a note of it. And when you're
Thanks, sir.
finished, done, can I go to the next part?
Yes, sir.
Good. So this part is done. Now let's go down to same thing. Now remember, the surface tension depends upon temperature. It depends upon the purity of the substance also. So we can write that surface tension depends on temperature and surface tension depends on the impurity, correct, in the substance. Now as far as the first part is concerned, there is a very single mathematical relation which tells you that surface tension at any temperature will be equal to surface tension at 0 degree Celsius into bracket 1 minus alpha change in temperature. Now remember, what is T0? T0 is equal to surface tension at 0 degree Celsius. Alpha is the coefficient and theta is change in temperature. Theta is change in temperature. Now, what is critical temperature? Critical temperature is a temperature where surface tension becomes zero. Critical temperature Tc is when surface temperature becomes zero. Surface tension becomes zero. Okay. Hello. Is this clear?
Yes, sir.
Yeah. Now, as far as impurity is concerned, there are two type of impurities. One is solvable, correct, soluble, and the other is non-soluble. If you add soluble impurities, your surface tension will increase. Your surface tension will increase. Okay. So if you add sugar or salt to water, its surface tension will increase. If you put a non-soluble substance, then surface tension will decrease. Surface tension will decrease. Now, very good example of this is soap. So when you add soap or a detergent into a water, its surface tension decreases and therefore it removes all the dust in the water. Okay. Is this clear?
Yes, sir.
Good. After this, we go to see how the liquid behaves when it is in a drop form. Okay.
Mm.
So let us look at it in this way. So let's go ahead and see this part. So let's say that we take a solid plate like a glass plate. So here this is glass and we have put two different substances on it. This is water and this is mercury. See the shape of the drop, it is different, correct? This is basically mercury and this is basically water. Okay. And we investigate why this is happening. So to begin with, what do? We take a glass or any solid and we look at the liquid over here. So let us say that this is our liquid. Now there are three substances. Over here we have got air or gas. Here we have got a liquid. And here we have our solid, correct? So at this point there are different type of surface tension. This is surface tension between air and solid. Here we have surface tension between air and liquid, and here we have surface tension between liquid and solid. And this angle over here is called angle of contact. We will discuss about angle of contact a little later. This is called angle of contact. Angle of contact. Okay. Now, if you resolve this at this point, so let us take this point, this force is very clear, this is TAS. Another force on the right is very clear, that is TLS. Now, we take the component of this element, हे जो होता TAL, we are taking the component of that and that comes out to be TAL cos theta. Now, for equilibrium, the force should be same, that is TAS, the force on the left should be equal to total force on the right, that will be equal to TAL cos theta plus TLS. Now look at this, your cos theta, if you work out, turns out to be TAS minus TLS divided by TAL. Now we have two cases. Case 1 would be when TAS is greater than TLS. That will make our cos theta positive. It will be greater than 0 or it will be positive, and our theta will be less than 90 degrees, like in the case of water. Like in the case of water. The second case would turn out to be when TAS is less than TLS, obviously what will happen? Your cos theta will be less than 0, it will be negative, and theta would be greater than 90 degrees, like in the case of Mercury. Is this clear? Hello.
Yes, sir.
बरं आहे, नोट केला? पुढे जाऊ.
No, exactly.
नोट करा. Okay, now we go to surface contact, and we'll also look at the type of meniscus that we can make. Okay. So first of all, we'll talk about liquid over here, and this is possibly a material of that substance. Now we look at the liquid surface here. Okay, so we look at the liquid molecule at the point of junction. तर आपण इथे एक molecule घेतोय. It has two forces. One is this force, that is force of adhesion, आणि इथे एक force आहे, that is force of cohesion. Correct? Now depending upon who's greater, we will get different type of meniscus. You could get a meniscus of this type, or you get a meniscus of this type, or you could also get a straight meniscus. Correct? So
Yes,
we'll
sir.
discuss the different situation. To begin with, we'll look at a situation like this, and this is our solid surface here, and here we have got a molecule at the point of intersection. Now in this case, our force of cohesion is much greater than the force of adhesion. Force of cohesion is much greater. Force of cohesion is much greater than force of adhesion. So the net force will be inside the liquid, and our meniscus would look like this because of the surface being tangential to the force, normal to the net force. Okay. दूसरा केस मध्ये, in the second case, we again look at the boundary between a solid and liquid. Here again we take one of the molecules on the interaction. Here this part is much greater than this. So force of cohesion, which you are talking about, is less than force of adhesion. So force of adhesion is much greater than force of cohesion. Net force is on the solid side, so its meniscus will be appearing like this. I made a mistake over here slightly. So here the force of the meniscus will be this type. हा असा वरती जाणार. It will go on the upper side. Here it will be on the lower side. So whenever force of cohesion is greater than force of adhesion, your meniscus will be convex. Whenever force of adhesion is greater than the force of cohesion, it will be concave. Is this clear? Hello.
Yes, sir.
If both of them are equal, so let us say that both of them are equal. दोन्ही equal आहे. हे पण equal आहे. तर इथं काय होतं आहे, फोर्स ऑफ एडेशन आणि फोर्स ऑफ कोहेशन दोन्ही इक्वल आहेत. देन आपला जो मिनिस्कस आहे तो लगभग स्ट्रेट असतो. करेक्ट? ओके. Now here we will discuss the angle of contact. Is this clear to you? Can I rub this off?
Yes.
Okay. Now let's look at the interaction that is happening over here again. So this is where our liquid would be, and let's say that our meniscus appears to be like this. So we look at a point of contact between the liquid and the solid. We draw a tangent to the surface of the liquid, and we measure the angle from inside the liquid, not outside. हे angle आपण नाही घेत, आपण हे angle घेतो. ठीक आहे? So we take an angle inside, and that is called angle of contact. This angle is called angle of contact. And remember, angle of contact also depends upon temperature. Angle of contact will increase with increasing temperature. Okay. Now, same way, if you look at another liquid, so let us say another liquid is there, and let us say that its meniscus is of a different type. Is the meniscus which we discussed earlier, it is of this type. Now here again we will be taking the point of contact, again we will be drawing a tangent, but the angle would be this. So in this case your theta is less than 90, in this case your theta is greater than 90. Is it clear? Thus also is called angle of contact. angle of contact. Are you clear about what is angle of contact? Hello?
Yes, sir.
Good. Now once we have done this, we will go to looking at the force on a concave surface. So let us say that we have a liquid which is convex in nature. म्हणजे तो असा दिसतोय आपल्याला. This is our liquid which is kept in a container. So let us say this way. So if you look at the surface tension at the bottom part, then the surface tension would appear this way to you. Correct? And this would be your horizontal. This would be your angle of contact on both sides. This would be capital T, this is capital T. So this will turn out to be T cos theta. This will also be T cos theta, which will cancel each other. Your net force will act upward, which will be 2T sin theta. So notice that the force is on the concave side. On the other hand, if you take a meniscus which is a little different in nature, sorry, so here we take a liquid whose meniscus is very different in nature. It is like this. Of course, I have aggravated the curvature of the meniscus. इतकं काय तीव्र नसतं तो. तर इथून आपण असं घेतलं की आपलं सरफेस टेन्शन असं खालच्या बाजूला असणार. It will be on the lower side. And if you take their movement, you will get this as, one second now, I'll redraw this whole thing. Okay, fine. So we take a container and we talk about the meniscus. Our meniscus happens to be like this. And we take this point, we have a T here, we have a T this side. And this is our horizontal. As we know, this will be equal to T cos theta. This will also be T cos theta, and the net force will be 2T sin theta, and it will act on the concave side. Is it clear? Hello? Okay. Now we look at pressure in a liquid drop. Difference in pressure in a liquid drop. Okay. So let us say that we have taken a liquid drop over here. Okay. And it has a radius. So we talk about its radius here like this. Okay. So we have a liquid drop and it has a radius. So obviously there would be pressure inside and outside. Inside the pressure, let us say inside the pressure is P and outside the pressure is P0. The difference in pressure would be P minus P0 and it will act in the upward direction. And because of this, what will happen is the liquid drop will increase in its size. It will increase in its size. So the liquid drop would appear something like this to us. Like this. Okay, fine. So in the beginning its radius was r. At present its radius will become r plus delta r. Delta r is this small portion. The small portion is delta r, dr or delta r. Okay. Hello, did you understand? Did you understand the part? पहिला आपण काय घेतलं, आपण एक लिक्विड ड्रॉप घेतला. करेक्ट. आणि आपण असं बघितलं की त्याची आतमधली जी रेडियस होती ती किती होती, ती आर होती. सो रेडियस ऑफ दिस लिक्विड ड्रॉप वॉज कॅपिटल आर. आतमध्ये प्रेशर किती होता, पी. बाहेर P0 होता आणि प्रेशर डिफरन्स हा होता. करेक्ट. या प्रेशरमुळे तोची सरफेस बाहेरकडे इट वॉज पुश्ड आउटसाइड अँड बिकॉज ऑफ दॅट व्हॉट हॅपन, द लिक्विड ड्रॉप increased its size. Correct. It went to this part, and because of which its radius now increased from r to r plus delta r. So it's this thing decreased from r to r plus delta r, and this delta r is this small portion of increase that is taken as delta r. Is it clear? Hello?
Yes, sir.
Now remember that its original surface area, let us say original was A0, which would be equal to 4 into pi into capital R square. The new area, because of the expansion, will turn out to be 4 into pi into bracket R plus delta R the whole square. So the change in area which are important for us to finding out the change in surface energy will be equal to new area minus old area, to which our 4 pi is common, and inside you will get, we'll open this bracket, so you'll get r square plus 2r delta r, and then we will get delta r the whole square minus r square. Now notice here that your r square and r square gets cancelled. This portion being very small is neglected. So our change in area which we are trying to calculate will become 8 into pi into r into delta r. So change in surface energy according to the formula which we learnt should be equal to T into delta A, and that should be equal to T into 8 into pi into r into delta r, correct? Hello, is this clear?
Yes, sir.
Okay. Now why is this happening? This is happening because of the force that is acting outward. इथून फोर्स जो आहे तो बाहेर ॲक्ट करतोय, करेक्ट? अँड वी नो
Yes,
दॅट
sir.
force is equal to pressure into area. So in our case the pressure is P minus P0 and area is equal to 4 pi capital R square. So the change is energy will be equal to the work done, which will be F into displacement, that is del R. If you put the values over here, you will get P minus P0 into 4 pi capital R square into delta R. Now both of them here and here, both are same, correct? So you equate 1 and 2 together, what will you get? You will get P minus P0 into 4 pi R square into delta R, and this will be equal to what? This will be equal to T. You will get 8, you will get pi, you will get R and delta R, correct? Now first thing is delta R and delta R we can cancel, pi and pi we can cancel, 4 will go in this 2 times, and you will be left with 1 R, correct? Okay, one of our R will get cancelled. Is it clear? So now
Yes,
looking
sir.
at it, you will get that P minus P0 will be equal to 2 times the surface tension divided by radius, correct? So this is the expression we were trying to figure out. Is it clear? Hello.
Yes, sir.
Okay. Yeah, please note it down. Hello.
Done, sir.
Done. Now instead of a liquid drop, if we are looking at a bubble, any form of bubble, so what will happen? We will end up getting what is called as two surfaces. There will be two surfaces in a bubble. One is outside and one is inside. So in this case, if you look at it, the pressure difference P minus P0 will be equal to 4 times capital T upon R. Is it clear? Hello. चला नोट करून घ्या. This is for a bubble, okay? This is for a bubble. That was for a liquid drop, okay? Okay, fine. Okay. This is also called Laplace equation. याला Laplace equation पण म्हणतात. Okay, next is we look at capillary action. So the most important part of it is capillary action. So we look at for a capillary action, what we are going to do primarily is we are going to take a very tube of very small radius. So we will look at a tube which is very small radius, correct? And we'll put it in a liquid, correct? We'll put it inside a liquid over here. 1 second. तर असं करणार की आपण इथे त्याला लिक्विडमध्ये ठेवणार, like this. The liquid is over here like this. आणि ही liquid जे आहे, depending upon what type of liquid it is, it will either rise or fall in this tube, okay? It will either rise or fall in this tube, okay? So this particular thing over here is the rise of liquid. This is called capillary action. Is this clear? Hello.
हाँ sir.
This is value is h. Now, in order to understand what we are going to do, we will enlarge this capillary tube. So we will take a big capillary tube like this, and we'll say that the water over here or the liquid over here has risen to this level. Now we look at the inner surface, so we take a point over here. The surface tension, if you look at the liquid drop, its meniscus would be something like this. So the surface tension would be like this. The reaction to this surface tension on the wall of the capillary will be this side. This is angle of contact, so this will also be theta. So this will become T sine theta, and this will become T sine theta, and of course this theta will become T cos theta. तो हा T cos theta होना, correct? Is it clear? Hello?
Yes.
Now if you look at this surface tension will act at every point over here, correct? So if you look at the periphery of the liquid drop, you will notice that the upward force will act at every point here. प्रत्येक point वर असा वरती force act करणार, correct? And that force will be equal to what? That will be equal to T into cos into theta. So the total force in the upward direction will be equal to T into cos theta into the circumference, that is 2 pi r. And as far as the horizontal part is concerned, every T sin theta will cancel with the T sin theta on the opposite side, correct? तर या लिक्विडवर जे वरती फोर्स ॲक्ट करणार आहे तो हा असणार, आणि खाली काय असणार? खाली त्याची स्वतःची वेट असणार. सो वेट विल बी इक्वल टू द मास ऑफ द लिक्विड इंटू जी. मास विल बी इक्वल टू डेन्सिटी इंटू वॉल्यूम इंटू जी, which will be equal to g into its area, that is pi r square into h into g. Now when both of them are equal, the upward force is equal to lower force, it will have equilibrium. That means to say when T cos theta into 2 pi r is equal to rho into this into r square, r square into h into g, one of the r will get cancelled, pi will get cancelled, correct? So you will get that the rise in capillary tube will be equal to 2 into T into cos theta divided by r into rho into g. So this is the expression for rise of liquid in a capillary tube. Is this clear? Hello?
Yes sir.
झालं लिहून?
हाँ, एक मिनट. झालं.
Okay, now let's look at some very important parts of surface tension for our question answers. Now remember, this is the surface of the plane. If the surface is down, net force outside and inside will be 0. If liquid is inside and outside there is air, then the difference in pressure will be this much. If it's a liquid drop, if it's a bubble, then this would be the pressure. If inside it is air and outside it is liquid, it will have atmospheric pressure plus the pressure due to the liquid inside. If it is curved this way, it will. So all this configuration of the liquid and its respective pressure, change in pressure is given. Make a note of it and then I'll go ahead. Have you copied it down?
Yes sir.
Okay. Now look at it. What over here you see is, we have a pipe. On one side of a pipe there is a smaller air bubble and there is a larger air bubble on this side. There is a stopcock. At present it is in equilibrium. If I open these 3 cocks, 1 and 2, and the first one is fixed, then it is the smaller one, correct, which will enlarge and the larger one will shrink. Larger one will become smaller and smaller and the smaller one will increase. Did you get?
हाँ.
Correct? From the smaller to the larger, so that smaller one will shrink, correct, while the larger one will expand till the small bubble reduces to zero. Did you understand this correctly? Because the pressure drop actually depends upon the radius. So wherever the radius is small, the pressure difference will be more, and wherever it is less, the pressure difference will be more. Correct? Hello. Did you follow this?
Yes, sir.
So excess pressure is inversely proportional to the radius of the bubble. That is, pressure inside the smaller bubble is higher than the pressure in the larger bubble. Correct? That is why when the two bubbles of the different side are put in communication, that means they are opened, the air will rush from the smaller to the larger. So ultimately the smaller will become very small and the larger will go on expanding. Is this clear? Hello. Can I move on to the next part?
Yes, sir.
Now here what we are seeing is we have two bubbles. One is of radius r1 and the other is of radius r2. When they combine together, their new radius will be given by this expression here. Correct? So just copy this expression for your part. So whenever you do a sum, you remember that this is what we are trying to figure out.
Thanks, sir.
Okay? तर हा एक्सप्रेशन आणि हे डायग्राम करून घे. ठीक आहे? कॅन आय गो अहेड?
Yeah.
Now suppose you got a capillary tube and the radius are not same. A radius is different. So एकामध्ये it will go up आणि एकामध्ये कमी येणार because of the change in radius. Normally both are of the same radius, then the liquid rise in the both the columns will be same. Here one radius is small and the other radius is higher. So the difference in height will be given by this formula. Okay, please note it down.
Thanks, sir.
Done? Okay.
Yeah.
So आता आज आपण surface tension, we have seen all the aspects. Now tomorrow there will be a class for you and tomorrow we will be doing the numericals pertaining to surface tension, and then we'll go down even to look at the other part of liquid. Okay, that is fluid
Also,
motion.
माझ्या क्लासवाल्यांनी ना थोडे चॅप्टर्स दिले जे इम्पॉर्टंट आहेत तर आपण
कशासाठी?
ते पहिलं करू शकतो का?
मला काय हरकत